on writing names and formulas for binary ionic compounds. That's all we are going to focus on, and we are focusing on writing formulas and naming binary ionic compounds that excludes the transition metals. And we are not working on transition metals today, because transition metals forms more than one charge. We're going to do that on a different video. All right. So ionic compounds, first of all, how do we know we are making ionic compounds? Here, if you have an element from this side, which is the stair step on the periodic table of this side, and then you have an element from the left side. So one is from the left of the stair step and another one is from the right side of the stair step. That means you're making an ionic compound, because ionic compounds are made up of metals and non-metals. Right? The compounds that we are working on are mainly from A group elements here, and then this side we are not working on transition metals, not working on B group elements today. So why are they binary? So now we know why are they ionic, but why are we saying binary? Because bi means two. It is made up of two ions, and the two ions, both those ions are monoatomic ions. You have cations and you have anions. Okay, cations and anions. Cations are the first part, so let's take examples. Maybe sodium ion, calcium ion, strontium ion. Anything with the positive charge, they are all cations. They are monoatomic ions here. And then anions, we can take example bromide, fluoride, maybe phosphide or nitride, oxide. So these are all monoatomic ions. As you see, they are one type of atom. Bromine here, phosphorus, oxygen, nitrogen, fluorine. And this is sodium, this is calcium and strontium. So let's move on. I'm going to start with this example of sodium chloride and ACl. Now, when we have to name these compounds, there is a rule. The rule says that you always name the first part, which is a cation. Cation is always written the first. So we always write cation first. And the name of the cation, this one, cation, anion. The name of the cations remains same. The name remains the same. All right. No change in the name of a metallic ion. And this one here, the name ends in IDE. Okay. So that's all you have to remember. So it's not that difficult. It's a simple rule that the first name remains same, and the second part, the anion, the name ends in IDE. So when you look at your periodic table, look for the name of Na, look for the Cl, and it is sodium and chlorine. All right, but remember the rule, you do not write chlorine, you write chloride. That's the rule. So the final name for this compound is sodium chloride. If you say sodium chlorine, then they will be elements. You have to write it like that. Let's take more examples. We can practice few examples here. How about KF? Look at your periodic table. Look for the names. Remember the first part, the name remains same. So you write potassium. The second part, the name ends in IDE. So when you name it, you are not going to write fluorine, you are going to write fluoride. So potassium fluoride. Similarly, Al, F3. The name of the cations remains same. This is aluminum. And again, fluoride. Not fluorine. Let's take another example. First name is calcium. That does not change. Name of the metallic ion remains same. And it is not going to be sulfur. It is going to be sulfide. So calcium sulfide. Okay? Just remember this rule of IDE for the second element. So you just learned how to write the names if the formulas are given. Now the second part is, how are you going to write the formulas if the names are given? So now you're writing, now you are given the names. Alright, and you are writing the formulas. So let's say you are given calcium oxide. You have to write the formula for calcium oxide. What you are going to do is, you need to know the charges on these elements. So there are several ways. You can use the valency chart, that's with the valency, or you can say with the oxidation numbers, or you can just look up with a different chart, or just if you know through the periodic table. So for example, all these elements, I think, yeah, I talked about this one. All these elements here in group 1, they have 1 plus charge. All these elements in group 2 have 2 plus charges. 3 is 3 plus. Here, keep going. Here, this one could be 4 plus or 4 minus, but we have exceptions here. As I told you before, some of the metals, some transition metals, and couple examples from here, they form more than 1 charges. Here from group 5, 3 negative charge, because 5 plus 3 is 8. Here 6 plus 2 is 8. So it is negative 2 negative charge, and 7 plus 1 is 8, because they all want to have 8 valence electron to complete the octet. So just remember by that, group 1 is 1 plus charge. This is another one. This is even more simple. Group 2, 2 plus, 3, 3 plus, 4, 4 plus or 4 minus, 5 is 3 minus, 6 is 2 minus, and 7 is 1 minus. In the middle, you have transition metals, and which we are going to talk about them later because of the variable charges with them. They form more than 1 ions. Just remember that compounds are neutral. So when you're writing the final formula, there should be no charges at all. All charges should cancel out, and it should be neutral. When you combine them together, it has to be equals to 0 charge. Okay. So we were talking about calcium. Calcium belongs to group 2. So 2 plus charge. Remember, the first part is cation. Just remember that. And you know, cations are metallic ions which form positive ions. And second one is here, anion, and it is 2 negative. Now when the charges are equal, so you can see 2 plus and 2 minus, it is simple, and it's now becomes neutral. The answer is CaO. That's all. This is the formula for calcium oxide. So this was really easy. So when you have equal and opposite charges, you just cancel them. I'm taking simple examples. How about when, let's work on an example when the charges are not equal. How about when the charges are not equal? You use the simple technique that is called crisscross. Okay, crisscross technique. So aluminum fluoride. When you write this, we are again going to look at the charges. Aluminum belongs to group 3. So it is 3 plus charge. And fluorine is in group 7. So it is 1 negative, or you can just write negative. You don't need to write 1. So when the charges are uneven, unequal, you crisscross. Okay. And when you crisscross, drop the charges. So you're going to crisscross the numbers only. And you drop the charges in your final formula. We don't have any charges because the compounds are neutral. AlF3. So what is happening? This 1 negative, 1 comes here, 3 plus 3 goes over here. Crisscross. But in the final answer, you don't put charges. There you go. So this is a technique to write the formulas when the charges are unequal. We can do more examples so that you have more understanding. How about calcium chloride? Calcium chloride. So for again, look in the periodic table, calcium and then chloride, you know you have to look up for chlorine. Charge for calcium is 2 plus and this one is negative. So what are you going to do is you are going to crisscross. Crisscross. Alright. So CaCl2. This 1 is right here. We don't need to write 1. It will be like this. Ca1Cl2. Ca1. There is no need of writing 1. Because it's obvious we have 1 calcium and 2 chlorine. So this was for calcium chloride. Let's take another example. Barium oxide. You look in the periodic table, charge on barium 2 plus, and for oxide, remember, you're not going to find oxide on our periodic table. We are going to look for oxygen, and that's the 2 negative charge. So what you're going to do in this case? Again, you cross it out because they are equal and opposite charges. So the final answer for barium oxide is just BaO. Okay, one more. And then we can, here. How about potassium sulfide? So you're going to look on the periodic table and the potassium, you're going to look for potassium and sulfur. Potassium is K. It's from group 1 plus charge, and sulfide, it is in group 6, sulfur, and it is 2 negative. 2 negative charge, you can use the chart, the valency chart, where the charges are already given to you. Here, again crisscross. Why are you crisscrossing? Because they are unequal. So K2S. So this 2 comes here. It was superscript here. It becomes subscript here. Here 1 plus 1 or 1, same thing, because how many plus you see? 1. So 1 goes here. It was superscript here. It becomes subscript here for the next one. And you don't need to write 1. It is you when you're looking at it, you can tell you have 2 atoms of potassium and 1 atom of sulfur. So that's the formula for potassium sulfide. So you can tell now why the potassium sulfide is written as K2S and not KS. And at the same time, you can tell why the barium oxide is not Ba2. Why the formula for barium oxide is BaO. Or we did this one. Why the formula for calcium chloride is not just CaCl. Why is it CaCl2? Okay, guys. So a little bit more practice. How about K2O? I think I did it. Oh no, I did potassium sulfide. So this one, when you're naming, simple. Look at the name of the first part and the second part ends in ITE. So this is potassium. No oxygen. Remember, oxide. No oxygen. One more. How about another example? Ca3N2. We will do the same thing here. Look at the periodic table for this and this. Calcium, the first name remains same, the second one ends in ITE. We're looking for nitrogen, and it is nitride. Okay, and let's do one more. How about, let's say you are given strontium nitride. Now you have to write the formula. So you're going to look for strontium and you're going to look for nitrogen. Strontium is Sr2+, it's in group number 2. Nitrogen is in group number 5. So remember 5 plus 3 is 8. So it is 3 minus charge. You crisscross and it is Sr3N2. Alright, so I think that's it. Maybe one more. Maybe one more. Magnesium chloride. What you're going to do is, again, look for magnesium and chlorine. Magnesium 2+, chlorine is negative. You do the crisscross, you get MgCl2. So you should be able to explain why the formula for magnesium chloride is MgCl2 and not MgCl. Because for one magnesium, we need 2 chlorine atoms. Remember, it is 2+ charge. So this needs to donate 2 electrons, meaning, but one chlorine needs only 1 electron. So magnesium is looking for 2 chlorine so that it can donate each of those electrons to each of those chlorine, both electrons to 1 each. Alright, thank you for watching.